In this video, we're going to be talking about the chain rule. So in the chain rule, there's a set of things you have to do in a chain, basically. So you have to do one thing, the next thing. So this works for composite functions, which is like an f of g of x. We did composite functions back in chapter 4 of Math 171. But instead of using f and g, we're going to use e for exterior and I for interior. We would use outside and inside, but then O for outside would look like 0, so we're just going to use interior and exterior. So exterior, inside. Okay? So what you do is you take the derivative of the outside function and then times the derivative of the inside. Okay? So, for example, the derivative of 5 plus natural log of x to the 6th. So as you can see, we have this inside function taken to the 6th power. We're going to first just treat this like it's an x inside there, like treat it like it's x to the 6th, and take the derivative of that. So it would be 6x to the 5th, right? Well, just write down what's inside there. Okay, and then take that times the derivative of what's on the inside there. So what's on the inside there is 5 plus natural log of x. The derivative of 5 is 0, and the derivative of natural log of x is 1 over x. So that'd be 0 plus 1 over x, or just 1 over x. So that's it. You might want to simplify it, rewrite it as 6 over x times 5 plus natural log of x to the 5th. But that's all you do for those. They get a little more complicated because sometimes there's more going on. This one is not. The next one is just, it's an exponential. So the derivative of e to the x is just e to the x. So, and when you have a constant outside, it's just that constant times that. So it's 8 e to the u, or e to the, in this case it's negative 3x, times the derivative of that inside function. That inside function is negative 3x. So we're going to take the derivative of negative 3x, which is negative 3. Okay, so it's the outside function, which for this one, the derivative of e to the x is e to the x, times the derivative of the interior function, which is negative 3x. Okay, and then you just simplify it. So we have negative 24 e to the negative 3x. Okay. When it gets a little more complicated is when you have other things go on. And for instance, here we have a power rule here. I mean a product rule with our chain rule here. Okay, so we're gonna treat it as a product rule, and then as we take the derivative of the second one, it is a chain rule. Okay, so remember that with the product rule, it is the first times the derivative of the second plus the second times the derivative of the first. Okay, so g prime of x will be the first, which is 4x, times the derivative of the second. Well, here's where our chain rule comes in. So this is e to the 6x, and then the derivative of the inside function, which is just 6x, is 6. Okay? Plus the second function, not 4x. The second function, which is e to the 6x, times the derivative of the first function, which is just 4. Maybe write the 4x down there. Okay, and you can leave it that way, or you can factor out the 4 e to the 6x if you would like. This will be 6x plus 1. Okay, in this next one, we're going to have a derivative that is a quotient rule with then a chain rule inside of it. And then we're gonna have to find the tangent line at x equals 1. Well, so to find a tangent line, we need the slope and we need a point so that we can find the y-intercept. So we have the x value here. We could go ahead and find the y value there, which would be f of 1, which is 1 over 7 times 1 minus 1 to the 6th. Minus 6 to the 6th. Okay, well, luckily 7 minus 6 is just 1, so this is 1 over 1, which is 1. Okay, we also need the slope, and the slope of the tangent line is the derivative at that point, the derivative, and then find the value at that point. So we're going to find f prime of x. So remember that for quotient rule, the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Okay, so the bottom is 7x minus 6 to the 6th power times the derivative of the top, which is just the derivative of x is just 1, minus the top times the derivative of the bottom. Well, this is our chain rule right here. So we have 6 times the inside function to the 5th power times the derivative of the inside function, which is just 7. Okay, and then divided by the bottom function squared. Okay, so just to clean that up a little bit, this is times 1. So this is 7x minus 6 to the 6th power minus 42x times 7x minus 6 to the 5th power divided by 7x minus 6 to the 12th power. Okay, I'm going to factor out a 7x minus 6 to the 5th power out of both of these top two terms and then cancel it with 5 of them in the bottom. Okay, so factor that out. I end up with 7x minus 6 to the 1st power minus 42x divided by 7x minus 6 to the 12th. Okay, well, if I cancel 5 of these out, I will have 7 left in the bottom. I cancel 5 out of the top and 5 out of the bottom. So 7x minus 42x is negative 35x minus 6 divided by 7x minus 6 to the 7th power. Okay, that is the derivative in general. We want the slope of the tangent line at x equals 1. So we want to find this derivative at x equals 1. So we're going to find f prime of 1. So negative 35 times 1 divided by 6 to the 7th. So that's just a 1 in the bottom because it's 7 minus 6 is 1 to the 7th power is 1. So negative 35 minus 6 is negative 41 for the slope. Okay, and then just take and plug it into y minus your y value is m times x minus your x value. Okay, so my x value was up here. My x value is 1. My slope I just found was negative 41. And my y value, which was right here, was 1. Okay, so you have, solve this. Y equals negative 41x. And this will be, when I distribute this, it'll be plus 41. But then I'm gonna add 1 from the other side, so that'll be plus 42. So that is my equation of my tangent line at x equals 1.